Okay, I think we're going to go ahead and get started. Thanks again, everyone, for joining on this morning or afternoon, depending on where you are, or evening. Just a quick overview of the agenda. I know some of you on the call, but a lot I don't. So just a quick overview of me. Those of you who haven't heard about Panasas, we'll talk just a little bit about it before getting into architecture later on. Talk about the way I see data storage issues in Cryo-EM, some solutions that may be out there for you, and then a little bit of a deep dive into the architecture and products, as well as how we work with respect to scientific collaboration with our customers. So a little bit about me. I am actually trained as a structural biologist, despite working for a storage company. I did my graduate work at UCSF studying the adenosine A1 receptor, which you can see there on the right. And I've worked in several industry locations, always as a scientist, until joining Panasas, where I help engage customers, support sales, and support the marketing team. I've been doing this for over 15 years, most of which is split between structural biology and genomics. So those are the two things I love the most. And I love being able to help our customers with those issues. Just a quick bullet points about us. We provide an on-premise data storage appliance. And one of the things that makes us unique is every one of our systems will have various types of storage media. And we'll talk a little bit more in detail about that later. Because we are a parallel file system, everything scales as you scale capacity. So as you grow your system, you get more storage space, get more protection, and you get more performance. And we're software-based such that you don't have RAID controllers to fail, which you may have encountered in the past. Generally, all of our features, users, and clients are included in the price. There's no per user pricing or per client pricing. And we've been around for about 20 years, meeting the needs of HPC in various different industries. So hopefully, at least the first half of this is not going to be a completely vendor pitch. I don't want to jump straight into talking about our products and how good we are. So there's not too many marketing slides. Bad news is I am going to ask for some participation in the form of surveys. It's way worse in person when I ask you to raise your hand, so at least you don't have to do that. And the goals here, just want to get that interactive survey. We've just got 2 questions to see what you're experiencing out there in the market, and then talk about what an infrastructure foundation for you would look like. First poll, I will pop this up, but question is, how often do you need to find your data over 2 years old? So your data that's older than 2 years or older, how often do you have to find that? So I will be launching this poll right now. All right, got lots of you answering. Thank you for that. I'll wait about 40 seconds if anyone else wants to answer. All right, thank you, everyone. And I'm going to quickly share the results. So you could see the majority here has to find their data more than once. Some people have never had to do it. And then a quarter of the respondents can't even find their old data. This is not surprising, and it's actually better than I expected. Oftentimes when I do this in person, if people aren't too embarrassed, I get a larger number of the participants saying they can't find their data. So moving on to poll 2. This will just be a simple yes or no. Do you think you can easily collaborate with users within your organization? Launching the poll now. wait a few more seconds. We've got still a lot of people participating. Thank you again. Okay. So it's almost 50-50. Definitely a large percent of you are unable to, or collaboration is not easy within your organization. And I'm sure it gets even more complicated when you talk about dealing with external organizations. So that concludes our 2 polls. Thank you again. And when I think about storage infrastructure and data management, I imagine this kind of thing as a goal. And what I've put here in the yellow box is a very high level, simplified SQL-like query. So basically, can you find certain types of data based on qualifiers? And here I just chose within a date range, the type of microscope, the grant, the researcher, and the organism. Many organizations can't even do this. So that really limits collaboration. And when we think about wanting to do this kind of query, the current answer probably exists across various storage arrays or even personal or local hard drives, like those external hard drives I showed a picture of just a few slides ago. So that leads us into these pitfalls that organizations face when developing and deploying storage infrastructure. Pretty much all of you are experiencing hundreds of terabytes or petabytes of storage, hundreds of terabytes at a minimum. In many cases, you're at petabytes or you will be very soon. And very rarely do I talk to an organization that has that all in one place. They're often in different piles, or a nice way to put it is silos. And many of them can be described as science projects. They're not really scalable options. They come from different vendors. A lot of them are home built. You can't just expand it easily and make it available to new users. In addition to those hardware infrastructure type issues, there's the software user interface side where there's no insight into the data. So when I say insights, I mean things like, do you know how old your files are? Do you know what type they are? Do you know how many times they're accessed? Do you know who owns them? Things like that. People have petabytes of storage and it gets to the point where they don't know what they have or where is it. And the problem with that is your data is no longer useful. There can sometimes be a keep everything model and you can't really do cleanup, but your applications need a foundation, need a data foundation where you can take advantage of that. That's so important for collaboration. And of course, it's important for all of the AI and ML initiatives that we keep hearing about. So what do I see in Cryo-EM and what you've probably seen? Here we have a single microscope, a single home-built network attached storage. This is something you could probably get on Amazon and buy some hard drives and plug it in and install a file system. Single GPU server in one lab. So this is pretty much how everybody starts. And this admittedly will work to a point. I see this working in single microscope, small labs for about a year. However, this is where it ends up going. Multiple microscopes, multiple separate storage systems, lots of different applications and workloads, something like a backup or old project directory storage systems, multiple labs. And as complicated as this is, it never stays there. This is where it ends up. You add more GPU servers, you have issues connecting to different storage systems. Systems are end of life, systems have different levels of performance. Labs end up keeping data for themselves, having to move it off because you run out of space. This is not a scalable storage solution for the Cryo-EM space going forward. There's too much data, too many different types of experiments, and the technology and the applications are just advancing so fast. All of you know that, so we want to keep you from falling into this pitfall here. Your time shouldn't be spent managing all of that storage madness I just showed. If you look at the plot on the right, that actually comes from NIH BioWolf, their storage cluster, and it shows the data usage among the cluster, which I do think is a good representation of data usage in life sciences worldwide. If you see imaging and structural biology, the red and black, that's about a quarter of all their data that they have. And then, maybe 60%, higher than 60 is genomics. This is from 2022, and structural biology and imaging has greatly increased since 21 and 2020. It is growing faster than genomics and is going to be it already is number 2 in data storage consumption in life sciences, and it may be half and half with genomics very soon here. So as it's growing, you need some type of way to understand your storage. As I mentioned earlier, can you do things like who owns it? How much do I have? How old is it? What are the data types? How fast is it growing? What types of technology are using the most storage? How do I plan for the storage I need as I add microscopes or new applications? So these silos, like we showed before, they need to be consolidated. Without doing that, it's very difficult to take action on your data sets to further those collaborations, to further the AI and ML efforts that many of you are working on or will have to be working on. And the reality is users suffer with poor infrastructure. They're here to do science. They're here to complete research, not deal with failing file systems or something's not able to connect, or they don't know where their data is, or they have to move it around. Your applications and your users really need that strong storage foundation to be effective. So how do we improve on this model? We saw this image earlier, and this is very commonly what we see. And as I mentioned, this is not a scalable long-term option. Our solution for that is a centralized scalable storage model. With something like Panasas, you can have multiple microscopes connected and writing at the same time, as well as multiple servers connected and writing it and running analysis at the same time, as well as multiple users. And when you use something like Panasas, a parallel file system, it scales with your needs. This is a single Panasas storage system, and you can expand it, and we'll talk about that a little bit later. You don't have to create a bunch of different storage arrays as you expand it. So if you have just /Cryo-EM as the top level directory that users are used to, you can grow that storage. They will get additional performance as you onboard users and application servers. So a little bit about how we do that. All of our systems are hybrid to some degree. So in this case, I'm describing our flagship hybrid system, which is called Ultra. And Ultra has 4 types of storage media: NVDIMM, NVMe SSDs, SSDs, and spinning disks. And what we do for you is map the data type to the ideal storage media. So your metadata will go to the low latency, ultra fast NVMe, small files go to SSDs, and large files go to spinning disks. This happens in parallel, so you can take advantage of all the disks on the system. This is not like a traditional tiering array where you have to think about, what do I move to hot? What do I move to scratch? What do I move to project? That kind of thing. And this is all configured automatically for you and handled automatically for you. You just see one storage array, or however you choose to configure it, but you don't have to think about where things are going. I don't want to get too much into the architecture here, but we certainly can have an in-depth call if anybody on the webinar would like to do that at some point. But the most common question I get, which is a very important question, is how do you expand the system? So all Panasas systems have a minimum size, and you would install that minimum size. And as you grow, you can expand by what we call chassis. You can expand by one or any number of them. And as you expand, everything is auto-balanced for you. You immediately see that new capacity, and you immediately get that that additional performance. Your performance will increase as you expand. So you don't have to think about creating a new array. You don't have to think about creating a new destination. That immediately becomes available to you. And as you're probably thinking, this is a huge deal when you upgrade your direct detectors, or you add another microscope, or you need a few more GPU servers. We do use something called erasure coding, which is all software based. We don't have RAID controllers. If you've built your own storage systems, chances are you've dealt with RAID controllers before. Those can fail and really compromise your chances of data recovery. We don't have that hardware failure possibility. And we do have minimum storage nodes and what are called director nodes. Basically, we are designed to have a high level of failure should that happen, to make sure your data is protected. In fact, your metadata is distributed across all of these storage nodes. They're not held on a single metadata server as some storage vendors do. And we'll talk a little bit about DirectFlow, which is our proprietary protocol for mounting the file system. DirectFlow is going to be your fastest and lowest latency method of mounting Linux servers. So generally, our Cryo-EM customers, all their GPU servers mount the file system with DirectFlow. We still can support NFS and SMB, but NFS and SMB are generally going to be slower. SMB you would only want to do with Windows, but there's not a lot of good reasons to use only NFS with Panasas. And if you're using something and you're running into the performance limit of NFS, with Panasas DirectFlow will get you around that. We can support all the main connectivity options out there: Ethernet, InfiniBand, and Cornelis or OmniPath. And our portfolio is 4 products. On the x-axis is capacity, on the y-axis is performance. The fastest and lowest capacity or equivalent capacity would be Flash at the top left. And then we have something called Edge, which is an entry-level product that in some cases is ideal for single microscope labs. Ultra is the product I described earlier. That's our flagship hybrid product, which offers the best ability to manage diverse workloads and scalability. And then XL is our largest, most dense product. All systems come with the same level of data protection as well as scalability. So it doesn't matter which one you choose to start with, you can still grow it. You aren't limited to any actual capacity in any one of these systems. In addition to our hardware portfolio, we have 2 software applications called PanMove and PanView. So when we think about making sense of your data or understanding your data or managing your data, these are the applications that you would want to use. So PanMove, and there's a small screenshot there, is policy-based movement from Panasas to any destination. So this is what you would think about using for your archive or backup or data redundancy. And we can write to S3, any S3 destination, NFS, or another PanFS system. And the screenshot here just shows completed jobs. So you'll have a very nice graphical interface that shows you if jobs complete, if they don't, what their status is. You could search through those jobs, everything like that. You could set policies for some directories and not others. It really enables you to help manage this high performance storage and these petabytes of data. On the right is a screenshot of PanView. So that's what tells you who, what, where, when, how much, how old. And it also has search functionality. So as you scale up past the hundreds of terabytes, it really becomes a challenge to know what you have, how fast it's filling up, who's filling up the fastest. We all know researchers leave or change roles. Sometimes they leave behind hundreds of terabytes or petabytes of data, and you may not know that they're not using it anymore. This really enables you to have those storage insights. So beyond our hardware and software, we do like to think ourselves as scientific collaborators. We really want to work with our customers as much as possible. We don't want to hand over a quote and say, okay, you're online, call us when you need a renewal. So just talk a little bit about how we can work with you, some Cryo-EM specifics about PanFS, and challenges you may face that are really agnostic to storage vendors. One of our biggest collaborations is with the University of Wollongong in Australia. I've divided it into 3 phases. So in year 1, they replaced a commercial NAS from a company all of you have heard of, as well as a home-built JBOD with Panasas. They got all their workloads on it, all of their users, and we actually did some joint marketing together. And that's definitely in no way a requirement. But for organizations, particularly academic ones, who want to get their name out there, we are absolutely willing to do joint press releases, joint collateral, opinion articles, things like that. So phase 2, which is where they are now, they've quadrupled their users, they've doubled the number of GPU servers, they'll be expanding their storage by 30%. And just recently, they saw a 30x increase in CryoSpark performance, which I will talk about just a little bit more in the next slide. For phase 3, which we've already started, they're evaluating PanMove and PanView. and working with us for their strategic planning for their next generation system and data transfer. So when their current system is end of life, they want to know what the next generation will be, how they can plan in advance for that, what it's going to look like, how it's going to handle their workloads and users. These are the things we are there to help you with. As I mentioned several times before, we do scale in performance, capacity, and data protection. So almost every Cryo-EM lab I've talked to is generating more data. Very few places say they're generating less. Most are adding more users, most are adding more projects, most are adding more GPU servers. So if you need to scale, we can support that scaling. With the recent release in August of CryoSpark 4.3, we saw about a 30x improvement in transfer rates to Panasas. CryoSpark made this improvement that improved the parallel file transfers, so it took advantage of Panasas technology. So we're seeing stuff that used to take hours down to minutes, and we suspect that only to get better. And our hybrid systems, they are designed to manage the data placement for you. So we do support different workloads. Some of you may be on mixed use systems or will have to share your system for mixed use. So things like genomics, tomography, optical microscopy, mass spec, all of those things that we're hearing, well, people have been talking about genomics for a while, but these other imaging technologies are really starting to grow in data generation rates. If you have to think about the future of research in your organization, and these things may have to share that storage, you may encounter them, we're the ideal choice because of how we manage different data types. So what do you have to deal with? You need to find a way to get out of these endless cycles of silos. Some of you on here probably have to deal with the /storage 1, 2, old projects, all kinds of different directories and figuring out what's where and physically where those are located. A lot of that comes from building your own storage from hard drives bought on Amazon. It's just not sustainable long-term when you should be working to advance research. Unfortunately, you may have to sell the idea of centralized supported storage to the stakeholders. If people think things are just working, they may not know how much better it really could be. And I have calculated the cost of maintaining separate systems in quotes. That's hard to really quantify, but if you think about downtime or maintenance or searching the forums to keep an open source system running, you can probably get an idea of how much of your support staff are spending on that and how that could translate to costs, as well as how it could translate to things that they should be better spending their time on, like supporting users' applications. And when you have to sell this idea to additional members within your organizations, we can provide proposals for you. And that's not just a line item of quotes. I have an intentionally blurred out proposal here, but we can talk about certain customers, how they're using our systems. There is a structure that I share from a recent Nature publication that was analyzed and created on Panasas storage. Talk about Panasas advantages, comparisons to other storage systems. So we can offer that commitment to you, that you have this to share to whoever you may need to, for your own reference, of course, and to whoever else you may need to get buy-in. And personally, I think storage, I know storage is critical to infrastructure and application success, but people often view it as an afterthought. So everybody gets excited about GPU servers and of course the massive expense of microscopes, but storage is so critical to what you are doing. It's a bit of a paradigm shift to have to think about it that way. But as we get our data generation rates so much higher than they used to be, and the GPU and CPU demands are so much higher than they used to be, storage is an ever increasing critical part of your infrastructure. And this comes from me. I do believe 80% of infrastructure challenges are social and 20% technical. I do think that technical solutions are out there. It's just making individuals aware and being able to get them installed and running. So as just a final conclusion, we provide the storage foundation for your data and applications. We can do all kinds of access models, work with what works for you. We know workloads change. We know types of research change, and that's why our data management system, data placement system can adapt to your different types of workloads. With PanMove and PanView, you can get the data insights and data movement. And with the Panasas system, and I have a tiny image here, all users will get the same performance. Unlike tiering, where you have to think about what's the hot directory, what's the cold directory, all users get that same performance and access to the same capacity. And you can grow that capacity and performance as needed. You may just need the original install and you're good with that. If you need to double it, we can support that as well. And with that, thank you for your time. Here's 2 emails. You can reach out to me directly or lifescience@panasas.com. We could certainly set up a call after this. We'd love to talk to you, and let me know if there are any questions. Okay, I've got one here, our PanMove and PanView included with Panasas. They are technically separate applications, so they would be a separate line item on your quote. Everything else, though, the enterprise features that you are used to, snapshots, quotas, things like that, the NFS, the SMB, direct flow, that all is included with your system. There's a question about Globus. Some of you may be familiar with Globus. It's a data transfer protocol. We don't package Globus, but several organizations do use us with Globus for data transfer. And system delivery, we can do anything. We had users during COVID who had to deploy the systems themselves, and they're up and running just fine. We can also do a fully configured rack and deliver that. So whatever works best for you, we can support. So we did get a question about if this is available in a PDF. So I think we will make this, we'll make it available in some capacity, probably on our YouTube or website. We did get a question about costs. Luckily, I don't have to get to address cost questions, but if you'd like to reach out to one of these emails, we can give you some ballpark numbers. Looks like there's, okay. We will wait a minute or 2 longer to see if anyone has any more questions, and then we can conclude. And again, feel free, amarco@panasas.com or lifescience@panasas.com. All right. Well, doesn't look like there are any more questions. And thanks again, everybody, for joining today. And I hope you have a great rest of your day and good weekend. And maybe we can talk soon in the future.